Alright, well let's have a go at this question 5. I'm doing this one from scratch, not for any particular reason, just to contrast it with editing their work solutions. I see which way seems to be more preferable. Okay, so they say we need to know the coordinates of this point C. Well, yeah, the pen's not working, that's great. Select that. If I make that distance there x, in other words, the point C having an x coordinate just given by some x value, then the y value will be e to the minus x squared. So that gives me the dimensions of the rectangle. If I get this highlighter, use the green, the bottom of the rectangle there will have a length of 2x. So we've got a length. I'm writing this because to draw a rectangle at the moment, I'm not having much success. And the width is going to be this length here, that side, and that's of course got the same height as the y value there. So the width is going to be e to the minus x squared. And so the area of a rectangle being the length times the width is going to be 2x times by e to the minus x squared. Now, once we've got that, we do the same process we always do. We differentiate to try to find a local max or local min. In this case, it'll be a local max. So we want dA dx. We're differentiating. This one's the product rule. Derivative of 2x is 2, so it's going to be 2 times e to the minus x squared plus 2x times by, now the derivative of e to the minus x squared, we've got to put down in front the derivative of minus x squared will be minus 2x times by e to the minus x squared. So it's just the chain rule there. Now we can simplify this. We can take out e to the, or 2 times e to the minus x squared as a common factor, leaving behind 1, and we've got a minus 2x squared. Okay, so I hope everyone can see where that came from. I'll get the highlighter. This and that has come out, and also that and that have come out as common factors. So what does that leave behind? Well, from here, that leaves a 1, because we've got like 2 e to the minus x squared times by 1. Remember, there's always a 1 there, and if we, of course, we take out the 2 e to the minus x, that leaves behind a 1. And what do we get left over here? We've got, if I can get this pen back, we've got a plus there. Now, removing the 2 e to the minus, 2 times e to the minus x squared that's in the highlighted blue, we've got an x, and we've got times by minus 2x. Now remember, that's a times, so I put it in brackets. Simplify that, you get minus 2x squared, which is what we've got here. So it's 1 minus 2x squared. Okay. Now we need to equate that derivative to 0 to get a stationary point. Where's my pen gone? For a stationary point. Now we know this part here, 2e to the minus x squared, that's never going to be 0. Just have to go back and look at your exponential functions. And you can see e to the x or e to the anything is never going to be 0. So that leaves us with solving 1 minus 2x squared equals 0. And that gives us 1, so being equal to 2x squared, a half equals x squared. So therefore x is going to be plus or minus the square root of a half, which is 1 over root 2. And you could put the square root of a half in your calculator and you'll get 1 over root 2. Or, the square root of 1 is 1, the square root of 2 is root 2. Now, this y value here, x, it could be over here, 1 on root 2, or the minus 1, but we're going to just select the positive one. So we're going to have x, because my x initially was from there to there, so they are positive values. I hope that makes sense. I'll draw it here. I let that be x, and that's a positive value. You could have worked all of this on the negative side, and you'd get the same answer. So we're going to have x equals 1 on root 2, given that x is greater than 0. Alright, we need a sign diagram. Here I go trying to draw a straight line. And remember, this sign diagram is for the derivative. And I've got 0 in that interval, so I can use that in my derivative to work out the sign. So if x was equal to 0, that would be e to the naught, which is 1, so it would be 2 times 1 minus 0 here. 1 minus 0 is 1, so it's going to be positive. And you can check if you wanted to put in a value, say 10. That'll still be positive there. 1 minus 200, it'd be, is negative. Or you can remember that this has an odd power. The factor that brought about that value, which I should label, is 1 on root 2. Should have done that at the start. Okay, so that means it's a local maximum there. Now it says, describe the coordinates of C such that the rectangle has a maximum area. Well, we've got the x value. Let's see if we can get this to work. We're going to get it to scroll. There we go. What we need is the y value. So we've got x is 1 on root 2. That gives us y. Don't know why it did that. Select the pen. Learning all the time with this stuff. Y equals. Now we've got to go back to our function up here. E to the minus x squared. So it'll be e to the minus 1 on root 2 squared, which is e to the minus a half. Now remember, that's a positive value. Just because it's a negative exponent, I can rewrite that's going to be 1 over e to the half, or 1 over root e, whichever way you want to write it. And that's a positive value. So the coordinates of C for maximum, our area is 1 on root 2, and e to the minus a half. And that ends that question.